Okay, that's how we do, or how we estimate our blurring function h through observation. Now we continue with the second approach, which is called experimentation. Okay, before we discuss about the slide, you need to let's discuss about this equation, because it's related to what we will discuss later in the slide. Okay, we know the facts that in order for us to find our g, okay, based on the formula, this is the two formula. Okay, this one is represented by, this one is in spatial domain and this one in frequency domain. Okay, but if you see this formula, okay, if, okay, let's say, if you can, uh, change this f with some sort of, I can consider it as low all pass filter. Okay, we already discussed this one many times. All pass filter, all pass filter. Okay, if our f here is all pass filter, okay, all pass filter, then meanings that, or identity transformation function, okay, it's also do the same. Identity transformation function or low pass filter will do the same, where if this is a low pass filter, I'm sorry, is this the all pass filter, then what happened here, then you can, at the end, if f your is all pass filter, then you can say that my gxy is equal to my h. Okay, which is, this is the one we want to estimate. Again, this is the one that we want to estimate. So if we can if we can generate some signal where that signal is actually an all pass filter, and we put it as our input image over here, okay, when it's passed through the system, remember the system is look like this. Again, this is our system. Okay, this one is our blurring function. Okay, and then this is our degraded image, or degradation function, a degradation image, where it's affected with this blurring function. This is ideal image f. So if let's say my signal here, if I can generate some signal over here, okay, some signal over here which is look like my all pass filter, then I can, I can get thing over here, the output image over here, which is similar to my hxy. So in other words, if we can inject some signal, that f over here, where that signal is look like our all pass filter, then we can, at this part where the image, we of course gxy here we can access, the produced gxy is actually equal to our hxy. So that's why we in this experimentation approach, we actually are doing this kind of approach, this kind of mechanism. We try to generate, at the input side here, we try to inject with some signal where that signal is an all pass filter. Of course, before we go deep into the discussion, let's discuss about what is all pass filter again, so then you can understand again what is all pass filter is all about, in spatial domain as well as frequency domain. So in order for to discuss about that things, let's go to this picture over here. So if you remember, if you talk about the all pass filter in time domain, okay, I draw it in one dimensional, so that's why I call it time domain. So it's actually the equation is look like this. Okay, so this is your if you draw this equation, okay, if you plot the equation, this is how it's look like. Meaning that if you have, for example, you want to compute your y end equal to your h end convolve with your x end. Okay, if your h end here is equal to if your h end over here, okay, equal to this hn, then at the end you will find out your xn after you convolve with this hn, after xn convolve with this hn, your yn is equal to xn. Okay, that's why if you talk about all pass filter in time domain, this is how it look like. Okay, and if I draw, it's only one impulse there at the 0, n equal to 0. So that's why if you convolve with anything, we get back this xn. Okay, so if this one is convert into Fourier transform, okay, again we talk about this one dimensional signal, this hn. If you convert into Fourier transform of frequency domain, if you apply the frequency Fourier transform, then the signal will become like this. If you plot, which is yep, something like this, number 1. Okay, so means that actually your h j omega is equal to 1. So that's why if you refer to Fourier transform table, anything which is in delta n in time domain, if you do a Fourier transform, it will become 1. Okay, so this one is delta n, Fourier transform, it become 1, because at the end, this is how the all pass filter look like. So once if you do multiplication at this stage, you are multiplying all f here. I'm sorry, if you apply multiplication, this one, sorry, I don't want to use this statement, this expression. Okay, if you want to process this thing in frequency domain, then if your h j omega here, this is how the process look like in frequency domain. So if my filter is all pass filter, I put it here, so it's now, because this one is equal to 1, then it's actually is my x j omega is equal to my x or j omega. So it's proof that this is all pass filter in frequency domain. If you convert into time domain, this is how the all pass filter is look like. Okay, so now the issue is, this is the one, okay, this is the one that we want to inject as our fxy. Okay, don't confuse that. Even I'm using the same h here, but h here in this case, I don't want this one to be put here. I want this one to be put here, because the one that we want to estimate is this one. Okay, so if we can inject some sort of signal that's mimic or it behave like all pass filter and inject as our f, then we can get our x, because now if this is all pass filter, we can get our h, because at that condition our h is equal to our g. So same goes to this one. Okay, if we want to at the frequency domain, if we can inject these signals, okay, these signals as our input here, then we can get our g here is equal to h, where h is the one that we want to estimate. So by having the all pass filter at this side, we can model or we can estimate our h, because now our h is directly we get from our g. So how to do that? That is how we do in the experimentation. Okay, if you see this image, I think I already draw this one. Okay, I already discussed about this one. Okay, if you see this one, okay, of course when we talk about the normal image which is in spatial domain, it should be something come from time domain. So how actually this one-dimensional signal in time domain can be converted into two-dimensional signal which is in spatial domain? If you see the terminology, of course, if I draw this one in 2D version, then this thing, okay, this thing should look like this. Okay, if this is my image plane, okay, if this is my 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 f amplitude fxy at the center there. So if I want to draw something like this in two-dimensional version, then it should be something like this. Okay, so there's a one point there at the center where that should be at 1, the rest becomes 0. Okay, at the center, just assume that you have the axis where this one is your x, this one is your y, then you only have one impulse at the center or at 0. X is equal to 0, y is equal to 0. So this is how it's look like. So if I draw it in proper image, okay, in metric version, sorry, so again this is where the ice is C from this direction. So if I draw it in the metric form, then I can only see everything here is in black, only one white dot at the center. Okay, one white dot which is at that point, which is represent this impulse, okay, or this single signals where the x is equal to 0 and y equal to 0, where at the center. So in other words, that is how we implement this thing. That is the idea on how they compute or how they proceed this experimentation approach. Meaning that in order for you to get your G, if you want to, if you want to get your image G x y is equal to your H xy, then your f xy must look like this. Okay, because this is the one that will make your f become all pass filter, and it will pass every single signal in hxy into your gxy. So that's why now your gxy is equal your hxy, where is this is the one that you want to estimate. You already access it directly through gxy. Okay, so that is the concept of this second approach, which is called experimentation. So if you can read the slide and the discussion there, that is how it look like. So this is the same thing, meaning that a here is equal to 1. Okay, a here is equal to 1, so that's why you can directly get your u v over here is equal to your gxy. So why a equal to 1? Because now this is the same as explanation of this one. Okay, because now your h j omega equal to 1, so you can directly okay, directly to it become like this. So that's why if your, in other words, if your f here become 1, then your g here is equal to g over a there, that is in the slide, that is written in the slide. Okay, a here is referred to this one 1. Okay, so that's how it's you obtain this h. Okay, just assume that your a equal to 1, so now you can directly estimate your h through your g, because that is you happen, okay, when you inject some sort of all pass filter as your f. Actually, when you access your g, that is actually your h. Okay, because g now is equal to h. So the rest, if you can see through this discussion, this is how this look like. This is the picture that I draw. You can see there's one dot here. Okay, so okay, to do this, I because I don't have any experience on do the exact experiment, but I can imagine if this is your, this is your camera. Okay, this is your camera. What you do, you just create one cardboard, black cardboard, a black cardboard. Okay, but you just drill one hole there. It's very very small drill one hole there. Okay, one small hole, a very small hole. And then what you do to this cardboard, you just place the camera here in front of the camera. And so and then what you do, then you put some very high lighting condition there. Maybe you put some, you know, some kind of light there to be direct into this one, so then it can generate some sort of this kind of image. The rest is dark or black. You only have very small one hole, where that hole is a very bright one. So that's how you can do. Then you capture that image. From there, actually you are actually producing this image, the one that we discussed before in this whiteboard. Okay, this one or this one. So that is how you create, or you create your fs. I'm sorry, you create your f. So your f is actually an all pass filter. So if that is all pass filter, then for sure the G that you obtain or you capture from your camera is actually can be estimate as your H. Okay, because G and equal to H when F is equal to all pass filter. Okay, this is the example. After they do this estimation, they find out that after the output they get from this image, they convert into Fourier transform into frequency domain. So this is how the H estimate H is look like after generate in 3D.